Hello, I am Dr. Sigarkanti. In this video, we study probability distribution. So, what is a probability distribution? So, we have the random variable and we can have the corresponding probability of that random variable. A systematic presentation of values taken by a random variable and the corresponding probability is called probability distribution of a random variable. For example, if I take two fair coins are tossed, that x denotes the number of heads, then x is a random variable here. Two fair coins means that is having uh, the different sides, okay, head or tail. We say that it is a fair coin. That is, two fair coins are tossed. And this is the random variable x. What this x is, this denotes the number of heads. Then we say that x is a random variable. So what are the possibilities of the values of x here? Suppose two coins are tossed, then the number of possibilities are I may get both the heads, or I may get the first toss head, second toss tail, or first toss tail and second toss head, or both tails. Okay, these are the possibilities. That means here x can take the value. If there is no head, then x value is equal to 0. If there is one head, then x value is equal to 1. If there are two heads, then x value is equal to 2. And here x cannot be equal to 3 here because only we are tossing two fair coins. The maximum possibility of getting head is equal to 2. And if we are not getting heads, then its value equal to 0. That is, x can take the value 0, 1, 2. That is, we write it. Probability of x is equal to 0. That is, it is the probability of not getting heads. P of x equal to 1 means this is the probability of getting one head. P of x equal to 2 means this is the probability of getting two heads. So here, the sample space consisting of this. S equal to both heads HH. First head, second tail is HT. First one is tail, second one is head is TH. And if I am getting both the tails here, then this is TT. So this is the sample space. And the number of elements in this sample space is equal to 4. That is, we write n of S is equal to 4. Now consider let A be the event of getting no heads. A be the event of getting no heads. So here we have, this is one outcome, here we have a head. This is another outcome, we have a head. This is another outcome, we have a head. This is the only outcome, this has no heads here. So that is here, my event A is equal to the set consisting of this element TT. And how many elements are this in A? This is equal to 1. And what is the probability of x equal to 0 here? That is, probability of getting no heads is nothing but P of x equal to 0. This is equal to n of A divided by n of S. That is 1 by 4. So 1 by 4 is the probability of getting no heads. And next, let me consider that B be the event of getting one head. Only one head. Then B is the set consisting of, see here we have two heads, and this is one outcome, here we have one head, this is one more outcome, we have one head here, and there no heads are here. So that means here B consisting of the set HT and TH. This has two elements here. So that is n of B is equal to 2. Then what is the probability of getting one head here? So that is probability of getting one head is equal to P of x equal to 1. P of x equal to 1. So here that means NB divided by NS. NB equal to 2, NS equal to 4. That is 2 by 4. This is equal to 1 by 2. 1 by 2 is the probability of getting one head. And next consider. Let's see with the event of getting two heads here. Then C consisting of, see the outcomes here. This is the only one outcome having two heads here. Here we have only one head, here we have only one head, and here we have no heads. So that is here C is the set consisting of the element HH. And number of elements in C is equal to 1. Therefore, probability of getting two heads is P of x equal to 2. This is equal to 1 by 4. N of C divided by N of S. These are the probabilities. And if I present these in the table, see here I will write in the first row we write variable. That is x is the random variable here. X can take the values 0, 1, 2. Okay. These are the possible values of x. And next in the second row, I will write probability of this x here. That is P of x. When x is equal to 0, P of x is equal to 1 by 4 here. When x is equal to 1, then the probability is 1 by 2. And when x is equal to 2, probability is 1 by 4. So this is, we are presenting x and corresponding probability x to px, x to px, x px. Okay. And here we can observe that probability of these are greater than or equal to 0. That no negative quantities. And if I consider the sum here, sum of the probabilities 1 by 4 plus 1 by 2 plus 1 by 4. This is equal to 1. So always we get sigma p of xi is equal to 1. Sum of the probabilities always equal to 1. And the probabilities of any value is always greater than or equal to 0. This is an observation here. Probability distribution of a discrete random variable. So here let x be a random variable which takes the value say x equal to something 1, 2, 3, 4 like this. Then and p of x is the corresponding probability. Then the function p is called the probability density function, that's PDF, or probability mass function. Usually we use this PDF. And the pair x comma px, that is the value of the variable, random variable, and the corresponding probability. This pair is called the probability distribution of the random variable x. And here we have p of xi is greater than or equal to 0, and summation of p of xi is always equal to 1. Next we define distribution function. The distribution function f of x of the discrete variable x is defined as f of x equal to p of x less than or equal to x. That is here, if I take x equal to 1, then p of x equal to 1. If I take x equal to 2, then this is nothing but p of x less than or equal to 2. That is capital X is equal to 1, capital X is equal to 2. And if I take x is equal to 3 here, then this is nothing but p of x1 plus p of x2 plus p of x3. Okay. So this is our f of x. And here we define the mean. Mean is defined as, mean usually we denote this by mu here. This is equal to summation x into p of x. This is the mean. This is the mean. And the variance is defined as sigma x minus mu square into p of x. This is the variance. Variance is defined as sigma x minus mu square p of x. And the standard deviation is defined as sigma is equal to square root of the variance. So that is here, to find these quantities, that is suppose the value of x is given here, x is defined, then what we do is to find these mean, variance and standard deviation, here we have to get the possible values of x here. Then what the values x can take. Then in the second row we have to write the corresponding probabilities here. So we have to find out probability of x when x equal to 0. That is p of x equal to 0. And here p of x is equal to 1. Here p of x is equal to 2. We have to find out probabilities of this random variable. That is, we have to make a table here. In the first row, we have to write the values of the random variable, and in the second row we have to write the corresponding values of the probability of this random variable. Then after writing this table, what we need to do is to find the mean here. Just we have to go for sigma x into px. That is, to find the mean here, what I have to do here is 0 into 1 by 4 plus 1 into 1 by 2 plus 2 into 1 by 4. Whatever the value I am getting, that is known as mean, and we denote this by mu. After finding mu, then to find the variance, you have to go for sigma x minus mu square into px. Suppose I get some value for mu, then again we have to go here. This is our x here. X minus mu square into this plus x. Here x is equal to 1 here. 1 minus mu square into p of this. And now x is equal to 12 plus 2 minus mu square into p of x, that is 1 by 4. So this gives the variance. After getting the variance, just we have to take the square root of this variance is nothing but the standard deviation. That is, here we can find out mean, variance, standard deviation. These are the formulas for finding mean, variance and the standard deviation. Okay. Thank you. I will stop here.